A very good evening to dear students. Myself, Dr. Rajashree Dhua, Assistant Professor, EEE Department, Swami Vivekananda Institute of Science and Technology. So, I am going to give a lecture on the subject Renewable and Non-Conventional Energy with the subject code BEEE 501C, which is an elective subject for the EEE students in the 5th semester. We have already discussed about unit 1, that is introduction, and now we are going to move towards the next important unit, that is solar energy. And this is a huge unit, so I have divided it into two parts. So now we are going to know about the course objectives. Now we have to understand what solar radiation is, what is solar constant, the concept of Earth sun angles, derived solar angles, attenuation and measurement of solar radiation, solar collectors, thermal storage of solar energy, solar ponds, solar water heaters, solar distillation, application like solar cookers, solar heating and cooling of buildings, the concept of solar cells, design of PV array, efficiency, and the concept of the application of solar cells and PV hybrid system. Now, moving to the concept of solar radiation. So, this is a very important concept. What is solar radiation? So, solar radiation is divided into two parts, that is the direct radiation or beam radiation and the diffuse radiation. So, what is direct radiation or beam radiation? The solar energy that directly comes from the sun and that has not been absorbed or scattered and reaches the ground directly from the sun is known as the direct radiation as described in this figure. So, this is directly coming to the surface of the earth. And what is diffuse radiation? Diffuse radiation is that solar radiation received from the sun after its direction has been changed due to reflection and scattering by the atmosphere. So as we can see, some amount of scattering is there and radiation is coming to the earth's surface. It is also reflected back by the surface of the earth and reflected back into the space. And some amount of radiation is also absorbed by the atmosphere, so leads to the warming of air. Now, both this radiation, when added together in the general sense, it gives us the concept of insolation at a particular point. And this is a very important concept, that is, energy radiated by the sun on a bright sunny day has a value of 1 kilowatt per meter square. Now, moving on to solar constant. Now, this concept of solar constant is very important. It is important for the exam purpose. So, how the solar constant is defined? It is defined as the energy received from the sun per unit time on a unit surface area that is perpendicular to the direction of propagation of solar radiation at the top of the Earth's atmosphere when the Earth is at its mean distance from the sun. And the value is very important. It is 1367 watt per meter square. And the extraterrestrial radiation is also given by this formulae, that is I external is equal to ISC into the fraction R average by R square watt per meter. This I external is the extraterrestrial radiation, ISC is the solar constant, R average is the mean distance between the earth and the sun, and R is the actual distance. So from there it is also given by this formula where n denotes the number of days of a particular year starting from 1st January. So both this formula are very important when we are trying to solve problems related to earth sun angles or solar radiation. And this value, that is the value of the solar constant, that is 1367 watt per meter square, this is also very important for the exam purpose. Now moving on to the concept of Earth sun angles, I am actually giving an idea about the variation of declination with the time of the year. So we can see that is declination delta. It will be defined later on as this variation which ranges from minus 23.5 to plus 23.5. So the declination can be written in a mathematical formula as 23.45 sine 360 by 365 into 284 plus n, where we know n is the number of days of the year starting from 1st January, and we also consider the concept of leap year. So we add this n, add it with 284, multiply it with 360, divide it with 365, get the sign of it, and then multiply it with 23.45 to get the value of delta in degrees for a particular place at a particular location. Now moving on to local apparent time, that is also known as LAT. So, local apparent time differs from place to place depending upon the longitude. As we know that the sun rises in the east, and any location in the east will have earlier sunrise and earlier sunset. So, the lat is something that is used to determine the concept of hour angle, that is omega. And also, the lat can be determined from the standard time by applying certain corrections. The first correction is needed due to the difference between the longitude of the location and the longitude of the place whose standard time is used to calculate. As 15 degree or 15 longitudes is equal to 1 hour, a correction of 4 minutes per longitude difference is given to the standard time. So we can write the formula, that is local apparent time is the standard time plus minus 4 into standard time longitude minus location longitude plus the equation of time correction. So these are certain formulae and definition that are needed as we gradually move towards solving certain problems. So this is the concept of local apparent time, also known as lat. Now, this is one important concept, that is the spectral beam radiation variation with the wavelength. So it is also defined as the spectral distribution of solar radiation intensity. That is how the beam radiation that is coming to the earth, how the spectrum is actually varying with wavelength, reaching its peak at this value of say 0.48 with a beam radiation value of watt per meter square micrometer. So this variation is very important, and it is